In today's lesson, we will explore linear equations and graphs that create parallel lines and perpendicular lines. To start out, let's graph the line y equals 1/2 x plus 1. So let's start at the y-intercept of positive 1 and then go up 1 over 2, up 1 over 2. And graph our first equation. Now we're going to graph a line that is parallel to this line that we just graphed. And it is going to be the equation y equals 1/2 x minus 2. So the y-intercept is at -2, and then use the slope of 1 over 2 to finish graphing. So here I have this line. So these two lines are parallel. What I want you to notice is between these two equations, what is similar between them? You should notice that they have the same slope. And any two lines that have the same slope are guaranteed to be parallel lines. Now, let's graph two different lines that are perpendicular and look at the relationship between them. First, let's graph the equation y equals 3x minus 1. So the y-intercept is -1, and then use the slope up 3 over 1 to graph. Now here's an example of a line that's perpendicular to it. Y equals -1/3 x plus 2. So let's graph this plus 2 for the y-intercept, and then down 1 over 3 for the other line. So if we connect these two, that wasn't quite a perfect line, but that's okay. These two lines are perpendicular to each other. So now, this one is not as obvious. We want to look at what is the slope of these two equations that makes them perpendicular. Well, you should at least notice that they both involve a 3. So we have the slope 3 and the slope -1/3. So we have one positive and one negative, and then we have 3 and we have 1/3. So the positive-negative relationship means that the slopes have to be opposites. And then the 3 and the 1/3 relationship means the slopes have to be reciprocals. So the relationship is if you have two linear equations in which the slopes are opposite reciprocals, they will be perpendicular, meaning one positive and one negative, and then the two numbers are reciprocals. Now here I have two examples of a linear equation, and we need to determine if the two lines are parallel, if they are perpendicular, or if they are neither parallel or perpendicular. So let's first look at y equals 3x minus 8. What is the slope? The slope is 3. And now the other equation, 3x minus y equals -1, we need to find out what the slope is. So let's rewrite this in slope-intercept form. I'm going to subtract 3x to the other side, so minus y equals a -3x minus 1. And now divide everything by -1. So y equals a positive 3x plus 1. So the slope in this equation is also 3. So because these two equations have the same slope, they are parallel. If you were to graph those two equations, you will have two different lines that are parallel. Okay, let's do the same thing with these two equations. 3x plus 2y equals negative 5, and y equals 2/3 x plus 6. Let's look at the blue equation first because it's already in point-slope form, or not point-slope, slope-intercept form, and the slope is 2/3. And now we have an equation in standard form. Let's move back to slope-intercept. So let's subtract 3x to the other side. So 2y equals a negative 3x minus 5. And now we have to divide everything by 2. So y equals a negative 3 over 2x minus 5 halves. So in this case, the slope is negative 3 over 2. Well, we can look right away and know that they're not the same slope, so they're not parallel. Now we just have to determine if they're perpendicular or not. Let's see, we have one is positive and the other one's negative. And then we have 2/3 and 3 over 2, 3 halves. And those are reciprocals, so they are opposite reciprocals. Therefore, these two lines, if you were to graph them, are perpendicular. Here we have two different equations of lines that are special cases. And let's just think about, let's draw a little picture. Let's see, x equals 10. We know that that is going to be a vertical line at x equals 10. And then y equals negative 2, we know is going to be a horizontal line at y equals negative 2. So if you have a horizontal and a vertical line intersecting, it's going to guarantee that they are perpendicular. So this is a special case that the slopes are not opposite reciprocals, but when you have one slope is 0 and the other slope is undefined, it will make it so the two lines are perpendicular. Alright, in this example, two equations written in standard form. I want you to rewrite them both in slope-intercept and then decide if they are parallel, perpendicular, or neither. For the first equation, you should get that the slope is negative 3. And for the second equation, you should get that the slope is negative 1/3. So they're reciprocals. We know that 3 and 1/3 are reciprocals, but if you notice, they're both negative, which means they're not opposite reciprocals. So these two equations actually represent two lines that are neither parallel or perpendicular. Okay, in this next example, it says to write an equation for the line that is parallel to this given line and that the new line goes through this point. So if you have the 0.5x minus 8 creates a line, we want to know what is the equation of a line that is parallel to it, and then our new line goes through the point 8, negative 5. So that's what we're asking. So let's look at what we know and what we can solve. A line parallel to this equation will have the same slope. So the slope of my new line is going to be 0.5. And then I know that I have this point, 8, negative 5. So let's think about what do you do when you know the slope and a point. You can plug that information into point slope. So y minus y1, my y value is negative 5, so I'm going to change it to plus 5, equals my slope, which is 0.5, times x minus my x value, which is 8. And it does not say this in the directions, but I would like you to write your final answer in slope-intercept form. So let's distribute. So y plus 5 equals 0.5x, and then 0.5 times the negative 8, so minus 4. And now we need to subtract 5 on both sides. So y equals 0.5x, and then negative 4 minus 5 is negative 9. So here we have an equation that is parallel to the original equation, and our new line goes to this point 8, negative 5. Okay, here's an example just like the one we just finished. I want you to try this one on your own. So go ahead and write this information down and pause the video. Try it on your own. We need to find an equation that is parallel to this one, in which our new equation goes through this point. So the equation y equals 3/5 x minus 2 is parallel to this equation and contains this point 5, 1. Okay, in this example, instead of parallel lines, we're dealing with perpendicular lines. So write an equation that is perpendicular to the equation given, but goes through the point 15, 12. Well, the equation given, negative 10x plus 8y equals 3, is not in slope-intercept form, so let's quickly solve it for y so we can find the slope. So let's add 10x to the other side. 8y equals 10x plus 3, and now divide everything by 8, so y equals 10/8 x plus 3/8, but simplify your slope, so y equals 5/4 x plus 3/8. So the slope of the original line is 5/4. So I need the slope of a line perpendicular to 5/4. And we have to think opposite reciprocal. Well, 5/4 is positive, so my new slope has to be negative. And the reciprocal of 5/4 is 4/5. So let's plug that information into point slope. Y minus 12 equals negative 4/5 times x minus 15. And now change it to slope-intercept by distributing first. Y minus 12 equals negative 4/5 x, and then negative 4/5 times a negative 15 becomes positive 12. And then I have to add 12 to the other side, so y equals negative 4/5 x plus 24. So here is the line that is perpendicular to the original but goes through this point. Okay, last example, just about the same as the one we just completed, but a little bit easier because this equation is already in slope-intercept form. So I want you to write down this information and pause the video, try it on your own, and then check your answer. So you should get the equation y equals negative 4/3 x plus 28/3. So these two lines are perpendicular, and this line goes through this point. So there's your full lesson on parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes.